Hello again, 6th grade. Welcome to a combo lesson between 723 and 724. Most of this is going to be something you already know, and I want to emphasize ahead of time that I'm going to be showing you another method for dividing fractions. However, keep in mind that I will also show you what I consider to be the easiest method and the one that I would recommend using. But just because it works really well for me does not mean that it will work well for you. I found that it's easiest, but that being said, you may find that this method just makes sense to you, so feel free to use that. Again, if it's not something that you like to use, you're going to be more than welcome to use whatever method fits you best. We're going to jump into this section on 723, and the first and most important topic that it's going to discuss are what are called multiplicative inverses, which is a really, really fancy word for reciprocal, which is a fancier word for a flipped fraction. And I'm going to show you what these are and how they work, and it's going to become part of your toolbox that you can use later on. And I'll show you why reciprocals are helpful and a couple of these things. So let's start off with this, where it says you are given some numbers like, okay, they're trying to figure out some pairs of numbers that will multiply together to give you 1. So I want to look at this and say, okay, 6 times what expression gives you 1? And a lot of times you say, well, wouldn't you just do 6 divided by 6? Well, you're totally right. 6 divided by 6 gives you 1. But when you're looking at 6 times some number, the way you do that is you write it as a fraction. 6 times 1 over 6 gives you 1. It is a reciprocal to 6. And if you're not sure why that works, you can multiply 6 times 1/6, which you write as a fraction, 6 over 1. 6 times 1 is 6. 1 times 6 is 6. 6 over 6 is 1. So these values are called reciprocals. So a reciprocal to 6 is 1 over 6. And when you multiply by a number by its reciprocal, you get 1. The reciprocal to 4 is 1 over 4. And you could also think of it as, okay, what is a quarter of 4? 4 divided by 4 is 1. And then you get into weird things like fractions, like 2/3. Same concept. The reciprocal to 2 over 3 is 3 over 2. And when you multiply that, 2 times 3 on the top is 6. 3 times 2 on the bottom is also 6. And 6 divided by 6 is 1. So these are called reciprocals or multiplicative inverses, which is a very, very fancy word because it changes a number when you multiply by its inverse back into 1. So if I wanted the inverse of 2/3, it is 3/2. The inverse to 4 over 5, or 4/5, is 5/4. And similarly, the inverse to 10/3 is 3 over 10. Now you might be saying, well, why are we doing this? Why did you not just say it's a flipped fraction? Specifically, there's a lot of useful things that you can use a multiplicative inverse or a reciprocal for. But for the most part, those don't really show up till later. However, there is a trick for dividing fractions that you can use an inverse for. So here is an example of how this will work. A student, Cheryl, was thinking about using a giant 1, which is just multiplying by a number over itself, to divide, and figured out she could use it with multiple fractions. Now, she had this fraction, which was 1/6 divided by 3/4. And she looked at this and said, well, I need to take 1/6 and divide by 3/4 and then try to get a fraction that will work. So I'm going to rewrite her work bigger. 1/6 is the top part of the fraction over 3/4. And here's where you see why I don't like this method. I don't like stacking fractions on top of fractions, but you can totally do that if this method works for you. So You stack the fractions. 1/6 divided by 3/4 turned into this. 1/6 divided by 3/4. And her strategy is to multiply the top number and the bottom number by the exact same value. So inside of her giant 1, I'm just going to use a giant parentheses because it's much easier to draw. The question is 3/4 times what fraction gives me 1? And here is where the reciprocal comes in. This 4/3 is the bottom and the top of this fraction. So if you recall giant 1s, you always had the same number on top and the same number on bottom. In this case, it's just a fraction on top of a fraction. So 3/4 times 4/3 gives me a 1 on the bottom, which means I can pretty safely ignore that for the rest of the problem. And the top number is 1 times 4 is 4, 6 times 3 is 18. And then I'm going to rewrite this fraction over a fraction because it's over 1 as just 4 over 18. It will reduce down by 2 to give me 2/9. Now, that's a lot of really ugly work because it's a fraction over a fraction, but if that makes sense to you and you want to use that method, you are more than welcome to. So I'm going to do another example of it just to kind of show you how to use it. 2/3 divided by 2/5. Let me put that over here. You have 2/3 divided by 2/5. Their strategy is to rewrite it as a giant fraction with the first number 2/3 on the top, 2/5 on the bottom. And you multiply the top and bottom by the same thing, which in this case is the reciprocal to the bottom. 2/5 and 5/2 make 1 on the bottom, which means we can ignore it. And then the top number, 2 times 5 is 10, 3 times 2 is 6. I'm going to, again, because it's over 1, I can just call it 10 over 6. Reduce both of these by 2, and I get 5 over 3 as my fraction. Now, you might be asking, why can't I divide using that method you showed a while back? You absolutely can. You 100% can. However, there will be times where you see a fraction on top of a fraction, and I want you to understand that you can do it using this reciprocal method. So it does have a time and a place and a use for it. If you would like, I'll go over the other method, which is when you divide fractions, you flip the second one and you multiply. And I'm going to show you these are the same thing. So dividing fractions, flip the second and multiply. 2/3 is the same. This division sign is now a multiplication. And my flip the second is now the reciprocal, which is the same term, 5 over 2. You may notice that this strategy of flip the second and multiply gives you the exact same problem as this reciprocal method. It's fine. Whichever one works for you, you can use. I prefer this first one, but I will tell you there will be times where fractions over fractions will be there, and you might benefit from doing it the other way. So you can leave your answer as 5/3, or if you really wanted to, make it 1 2/3, but that's not necessary. Okay. So that's another method. If you would like to practice on part B and C, I would like you to do so. And I will show you the other way that this can be useful is taking a ugly fraction or an ugly decimal and then changing it into something that's much easier to use. A lot of students struggle with dividing decimals because there's a whole lot of extra steps involved. But you can use this strategy of simplifying fractions in order to make this easier, and I will show you how. So you can take this 0.006, which is 6 thousandths, can be written as 0.006 divided by 0.25. This can be rewritten as 6 thousandths divided by 25 hundredths. And if you're not sure how I got those, it's because this is the 10th spot, which is the out of 10. This is the 100th spot, which is out of 100. Okay. And then this is the 1000th spot, which is out of 1000. So it's 6 thousandths. And you could use this simplification technique if you'd like, or you could just multiply them the way that they are. You could have 6 over 1000 over 25 over 100. You could multiply the top and bottom by something to make it simpler, or you can just flip the fraction and then multiply. It will give you the same thing. So you could multiply by 100 over 25 because it is the reciprocal. Okay. And then you get 600 over 25,000, which reduces down to 6 over 250. Or you can, and then the bottom is 1, so you can leave it like that, or reduce it by 2. It's really just a trick for doing this. I personally, if I am asked to divide fractions, when I'm doing this, I will take the decimals and put them into a fraction, 0.006 on the top, 0.25 on the bottom. There is a trick with multiplying by tens, and I will look at this and say, well, there's 3 decimal places here, so I'm going to multiply the top and bottom by 1000. What that's going to do is it's going to move this decimal 3 spots to the right, which becomes 6, and this decimal goes 3 spots to the right, which becomes 250. And then I can then reduce this by 2 to get 3 out of 125 and leave it like that. So I personally like to use thousands in a nice way, especially when you've got something with 3 decimal places like this. You can actually make this a much easier problem. So I'd like you to pause the video, and I'd like you to divide the fractions in 7-72 using whatever strategy makes the most sense. I personally prefer the flip and multiply method. So pause the video, try those, make sure that you end up getting 24 over 25, 30 over 12, and 21 over 16. And you can again reduce some of these. I will very strongly advise you to not look for another shortcut on this because it will result in mistakes later. And if you are already looking at this and thinking, oh man, I've got this really cool shortcut for dividing, it's looking like, well, I strongly recommend that you do not try to use whatever shortcut you think you have. The only shortcut I would advise using on this is to flip the second fraction and then multiply the first fraction times the second fraction after it's been flipped. And so on part B, the 5 over 12 times 6 over 1, 5 times 6 is 30, over 12 times 1 is 12. That can reduce again, so you can reduce that down by 6. 30 divided by 6 is 5. 12 divided by 6 is 2. When I say you're looking for a shortcut, I'm talking about things like multiply the 5 to the 6 and the 12 to the 1, however you're looking at that. Some people see that and it's a shortcut they think they can do. They will make mistakes later. Just trust me on that. Don't go looking for shortcuts. On 7-164, it asks you to do this without a calculator. Couple of pieces of advice. When you have a mixed number, you need to convert that into an improper fraction. 4 times 3 is 12, plus 1 is 13 over 3. Divided by 6 times 1 is 6, plus 1 is 7. Then you can do the flip and multiply. I would take this one as 8.06 over 2.48. I would advise you see, oh, 2 decimal places. Let's times top and bottom by 100, because you can times by 100 over 100 to whatever you want. It's just a giant 1, and then you're going to have a 806 divided by 248, and you can reduce that accordingly. For part C, do that the same as part A. Again, convert it first, and then do whatever division method works for you. Multiplicative inverse is pretty easy for 7 over 8. It's just 8 over 7. And then you start getting into some interesting ones like 1 and 2/3. Easiest way to do an inverse is to then do improper fractions. 3 times 1 is 3, plus 2 is 5 over 3. Your multiplicative inverse then is 3 over 5. Okay. For 1.5 and 0.25, you could write this as 1 and 5/10, or 1 and 1/2, or 3/2, or whatever you wanted. Heck, you could even make the multiplicative inverse 1 over 1.5. Okay. 7-67, I want you to practice multiplying fractions and decimals. Again, when you multiply fractions, you do not need a common denominator, so don't do that. For C and D, convert them into mixed numbers first. 3 times 1 is 3, plus 1 is 4. Make that 4/3. 2 times 6 is 12, plus 1 is 13. And then you just multiply across. Make sure you're looking at the fact that these are multiplication. On 7-74, again, it's jumping into the next lesson. Divide using whatever method works for you. I don't care what you do, but when you're dividing part C, you really, really want to do improper fractions first. 3 times 8 plus 1, 25 over 8, divided by 5 over 2. And when you name the coordinates, I do not mean name them like Ted or Chuck or Billy. You list out the coordinates for point A. When you list your coordinates, X comes first, and then Y. If you forgot which one comes first, you sing your ABCs. W, X, Y, and Z. So when I list out the coordinates for point A, it is 1, 2. For point B, it's over here, it is 4, 1. Okay. That's all I have for you this week. Best of luck, and if you want to be notified when these go live, hit the bell button, hit the subscribe button. Bye-bye.